All right, guys, welcome back from your February break. What I'd like to talk to you about is composition functions. So we're kind of moving through chapter 3. We've talked about a lot of different stuff. This chapter has a lot of different stuff. We talked about function notation before we went away on break. We talked about how to use it, how to add functions, subtract functions, multiply and divide. But there's another thing we can do, and it's going to involve basically being able to put a function inside of another function. Right? So, quick reminder. This is what function notation looks like. Right? Here's where whatever my input value is, right? I'll then replace. So if I say, what if I'm looking for the function at 3, f of 3? So well, in that case, I'll take I call it the rule, right? I'm going to plug 3 in, and that's how I'll get my results. I'll typically throw these up on the board. I say, does anybody know what these are? Can you explain them to me? So take a pause right now in the video. Try and think about either what this is here, or have you seen this movie? I always kind of date myself a bit. And I'm like, oh, this came out when I was, in high school. But that was a long time ago. But these are Russian nesting dolls, right? So it's a doll within a doll within a doll all the way down to the bottom. This movie Inception, right? DiCaprio, he's going to a dream within a dream. So these are two things that are kind of like real world that might make it easier just as a stepping stone to get us into a composition function, which is a function within a function. So you take an input, you plug it into a function. Then whatever you get as your output becomes the next input for the next function. So here's what the notation looks like. Here's g of x, here's f of x, and if you see this, like a literal circle, not a dot, that would mean multiplication, an actual circle. That means g of f of x. You'll typically see it like this, though. I just want to show you this way, but honestly, typically, I'll give it to you like this. H of g of t. I think that makes it easier to think about, too, because you're kind of like working your way towards the outside, where it's like, clearly I need to start by figuring out, I need to plug in t to g. And whatever I get is now inside the parentheses for h. So whatever I get as a result becomes the input for this function h. So some great examples. This is a good slide to pause the video on and take a look here. So what it teaches us is that just like we could write a new rule, which we practice doing for addition, subtraction, we do the same thing here. If I was saying, hey, we're going to come up with a new function, h of x, and h of x is going to be made of g of f of x. What do you need to do? Well, it means you need to take g, and instead of plugging in x, instead of plugging in the input, what is the new input? The input is this output. So the input becomes 3x plus 2. So I now, instead of having x plus 5, what I really have is 3x plus 2 plus 5, or the reverse. What if I wanted you to do f of g of x? Well, the way function f works is that whatever my input is, I multiply it by 3, and then I add 2. But now I'm saying I don't want you to multiply the input by 3. I want you to take the input, x, plug it into g, and then when you're done with that, plug that in over here. So you're really doing 3, not times x, but times x plus 5, and then you're adding 2. And that's how you can get new function rules using this operation, creating a composite. So here's a good example. All right, so let's talk about how we get here. H of g of t, meaning this becomes the input. So what I'm doing is 2t plus 1 squared minus t. I could do table method if I wanted to, help keep myself fresh on that strategy, right? I'm doing, when you're squaring something, you're multiplying it by itself. So 2t plus 1. Ooh, and I love when I catch mistakes in the middle of even my own videos. All right, we'll turn this into a learning moment. What did I forget to do? I was getting ahead of myself and saying, yeah, I'll just put this here. But if this is becoming the new input, it also needs to replace this. So it's minus another 2t plus 1. I'm glad I caught that. And it shows why these things can be hard, right? I caught myself there. So this will be 4t squared. Two t times 1 is 2t. Same thing here. And then I have 1. So in total, 4t squared. In total, that's 4t plus 1 minus g of t again, right? The g of t is becoming the new input for h, meaning everywhere that I normally would replace just a number, here and here, becomes 2t plus 1. So that's going to be minus 2t, so suddenly that gets me from 4t to 2. And 1 minus 1 is why there's nothing here, right? Plus 0. And that's how we get our new rule. And you're probably thinking, okay, that seems kind of like a lot. I think it is probably a little bit easier when there's numbers. I've said this before. Sometimes it's harder writing the rule because it's all very hypothetical than it is to say, all right, here's an actual number, 5. What do I need you to do? Now let me start, right, by saying, like I said, it can be tricky to see it like this. Sometimes it's easier to see it like this. It's f of g of 5. So work your way from the inside out. Think about it. What I'm asking is, put 5 into g. When you've completed that task, so let's do that. What's g of 5? 5 minus 4 equals 1. So if I know that g of 5 is 1, I'm now going to take f of 1. So I'm not plugging 5 into both of these. That's the tricky thing. I'm not plugging 5 in here and here. I'm plugging 5 first into g, and then when I'm done, okay, 5 minus 4 is 1. Now I'll take that new result and plug it in here. Okay, so f of 1 equals 1 plus 2. And that's how I get 3. I would like you guys to try on your own. This would be a great one for you to pause the YouTube video right now, try this one on your own, and I mean, I'm going to immediately start doing it because hopefully you've paused and then you'll hit play and I'll be getting started. So f of g of negative 2. So why don't I start with negative 2 going into g. So I need to start with g of negative 2, which is negative 2 plus 1, which is negative 1. So what I've learned is g of negative 2 is negative 1. So if g of negative 2 is negative 1, then when I take f of g of negative 2, I'm now going to take negative 1 and say that is what's going in here for f. So f of negative 1 is negative 1 squared plus 3 times negative 1. So it's going to be negative 3, but plus a positive 1, which is going to be negative 2. And that's my final answer. All right. What we're going to do for the rest of class today is we are going to practice this skill. This is going to be something that we're going to focus on all week because I want to make sure we really build that proficiency, that competency. I know this is new, but try to keep a growth mindset about it and know that every single day you're training your brain to get better at this stuff. And I'll wrap it up there.